We are ready to solve absolute value inequalities. So the first one we're going to look at says that the absolute value of x, the absolute value of a number, is less than or equal to 3. So think about this. We are trying to find out something about a number whose absolute value is less than or equal to 3. And here's what you need to think. We need to ask ourselves what numbers have a distance from 0 of less than or equal to 3. Okay, so we know that the absolute value of 3 is equal to 3. We know the absolute value of negative 3 is equal to 3. Now, what is a positive number and a negative number that have a distance from 0 of less than 3? Well, you could answer anything between 3 and negative 3, right? The absolute value of negative 2 is 2. That's less than or equal to 3. The absolute value of positive 1 is 1. That's less than or equal to 3. So everything between negative 3 and 3 has a distance from 0 of less than or equal to 3. So my solution, notice this is an AND inequality, is that x is between negative 3 and positive 3. So I wrote it lowest number, all my symbols are less than, positive number. Negative 3 is less than or equal to x is less than or equal to 3. Now, let's look at the absolute value of x is greater than or equal to 3. In this situation, we're going to ask ourselves what numbers have a distance from 0 of greater than or equal to 3. Well, we already know 3 has an absolute value of 3. Negative 3 has an absolute value of 3. Can you think of positive numbers or negative numbers whose distance from 0 is greater than or equal to 3? Well, everything to the right of positive 3 has a distance from 0 of greater than 3, right? The absolute value of 4 is 4, and that's greater than or equal to 3. But also, everything to the left of negative 3 has a distance from 0 of greater than or equal to 3. The absolute value of negative 5 is 5, and that is greater than or equal to 3. So hopefully you recognize that this is an OR situation. We want to look at both sides and write the inequality. Well, the one on the right is going to be pretty simple. It's x greater than or equal to 3. And the one on the left is that x is less than or equal to negative 3. Okay, so a couple of things. Notice that on the less than absolute value inequality, things are coming towards 0, and I end up with an AND. And on a greater than absolute value inequality, things are going away from 0, and I end up with an OR. So here's how I solve this. This first one says the absolute value of x plus 3 is greater than 8. And I'm going to use what I call a helper number line. So I'm going to put, I know that my key numbers here are 8 and negative 8, right? 8 is not included, so I'm going to put open circles on 8 and negative 8. And the distance from 0 is greater than 8. I'm going away from 0, so I'm going to do an arrow this way. Those numbers have an absolute value of greater than 8. And this way, those numbers have an absolute value of greater than 8. So this is going to be an OR. So we're going to write OR. We're going to lift what is in the absolute value out of the symbols. Do not write the symbols here. And on the left side, x plus 3, everything over here is less than negative 8, or x plus 3. On the other side, going this way, is greater than 8. So now we have two inequalities that we're going to solve. We're going to subtract 3 from both sides, and we get x is less than negative 11, or subtract 3 from both sides, we get x is greater than 5. So the numbers that make this inequality true are anything less than negative 11 or greater than 5. The next one says that the absolute value of 2w minus 1 is less than 11. So on my helper line this time, my key numbers are 11 and negative 11 because the absolute value has to be less than 11. 11 is not included because there's not an equal to, so I'm going to have open circle. And what numbers have an absolute value of less than 11? Well, everything that comes toward 0 has an absolute value of less than 11. So this is an and. So we're going to take that 2w minus 1. We're going to lift it out of the inequality. And an and can be written between two numbers, right? So we're going to say negative or less than 11 on the right, and negative 11 is less than 2w minus 1 on the left. So make sure yours looks just like this. Remember, we solve from the middle. We're going to add 1 to all three parts because we're solving 2 at the same time. So negative 10 is less than 2w is less than 11 plus 1 is 12. We go back to the middle. We're going to divide everything by 2, and we get negative 5 is less than w is less than 6. So every value of w that is between negative 5 and 6 will make this inequality true. So here's where things are going to start to get sticky. So I have the absolute value of negative 4x minus 5 plus 3 is less than 9. So just like when we solved absolute value equations, we have to isolate the absolute value before we do anything. So I have the absolute value plus 3 is less than 9. So I'm going to subtract 3 from both sides, and I get the absolute value of negative 4x minus 5 is less than 9 minus 3 is 6. Now that the absolute value is isolated, I'm ready to figure out what to do. So I look at that 6. That means on my helper number line, my key numbers are 6 and negative 6 because those both have an absolute value of 6. There's not an equal to sign, so these are open circles. And where are the absolute values of numbers less than 6? Well, it's numbers that are closer to 0, right? So I'm going to go towards 0 this way and towards 0 this way, and I end up with an and. So we're going to lift the negative 4x minus 5 out of the absolute value symbols. We don't need the absolute value symbols anymore. And we're going to place it between 6 and negative 6. Notice that both of my symbols are less than. Notice I have the negative 6 on the left, the positive 6 on the right. Now, this is, we're going to solve this compound inequality. We're going to solve from the middle. So we're going to add 5 to both sides. Negative 6 plus 5 is negative 1. And what are we going to do next? We are going to divide by a negative 4. And what happens when we divide an inequality by a negative number? We have to reverse the inequality. So negative 1 over negative 4, just leave that as a fraction. That's 1/4. That less than becomes greater than. These cancel. I'm left with x. That less than becomes greater than. And 11 divided by negative 4, that's just a negative fraction, negative 11/4. Now here I have the greatest number down to the least number. So I'm going to rewrite this the other way, and I'm going to say negative 11/4 is less than x is less than 1/4, just because in general I want to go from least to greatest, and I want my symbols in an and to be less than. One more. I have 3 times the absolute value of 5m minus 6 minus 8 is greater than or equal to 13. The absolute value symbol is not isolated yet, so I need to isolate it. I'm going to treat this like a two-step equation. If I had 3x minus 8 is greater than or equal to 13, what would I do first? I would add 8 to both sides. And then I would end up with 3 times the absolute value of 5n minus 6 is greater than or equal to 13 plus 8 is 21, right? So I would have done that over here. Now, I have what is basically a one-step equation. What would I do for 3x is greater than or equal to 21? I would divide both sides by 3. So I'm going to divide both sides by 3 here, and I end up with the absolute value of 5m minus 6 is greater than or equal to 7. You cannot do anything until the absolute value is isolated. So now that the absolute value is isolated, it's greater than or equal to 7, just as it would be if this had been something normal. Means my key numbers on my helper number line are 7 and -7. Now, it can equal 7, so I'm going to have a closed dot on both of those because the absolute value of both of those equals 7. And then the absolute value is greater than 7. Well, what kind of numbers have an absolute value of greater than 7? Well, everything to the right of +7 has an absolute value of greater than 7, and everything to the left of -7 has an absolute value of negative or greater, I'm sorry, an absolute value greater than 7. So this is an OR. Look at the left. We're going to lift the 5n minus 6 out of the absolute value symbols. On the left, that is less than -7. And on the right, that is greater than or equal to, I almost lost that equal to, didn't I? +7. Okay, so I want you to solve these two inequalities and tell me what your final answer is. I got my final answer as m is less than or equal to -1/5, or m can be greater than or equal to 13/5. We are ready to do some practice.